So that's what I'm going to do. You can either run this attack against a live interface or against a PCAP file. For the demo, I will use the PCAP file because this is hell more reliable. And this PCAP file just includes one TCP MD5 signed SYN packet. And you will see after 6.2 seconds, we found out of a word list with 4 million entries the right password. This means, okay, MD5 is really short to generate. You don't need much CPU power, and you can even do real brute force if you get some hardware tweaks. Okay, but this shows, okay, your MD5 secret is not unbreakable. Okay, once I got this secret, I can do the following, configuring this secret in the BGP CLI for that peer. After that, setting up the session again and connecting to this peer. You see there is no more timeout appearing. Instead, we got a real neighbor up and running. And again, we are connected. We got a connected BGP session. After that, we can insert whatever we want into the BGP routing process. So building the update statement again, sending an update, and we got a new routing entry. This time, our other host is the next hop, but we got routing entry into the global routing table of this router. Okay, so that are these for short. You can do a lot of other nasty stuff. You can withdraw some other routes. You can insert, I don't know, some crazy routes, some malicious BGP statements, like something with an AS path of 255 entries, stuff like that. Okay, so, yeah. Okay.
Have you looked into any kind of buffer overflows and code execution vulnerabilities through the BGP session
We haven't searched for that. We're just focusing on BGP is just the main part. We need BGP in another context to insert something into the MPLS stuff, but you will see later on. So it was just the basic to write these tools.
Yeah.
We didn't do any more research into BGP itself because its implementation, it depends on the implementation, if it's a Cisco device or Juniper or whatever. We saw something other. We saw some main problem with the design.
Yep. Thanks.
Okay. So please wait till the end. We need to go on because we don't got much time. So for completeness, this is what we found in an audit in a big 40K user backbone. We find this configured BGP MD5 key and decoded. It's just like, Cisco. The default of the configuration manual. So they want to make it secure, but actually they didn't add any security at all. Okay, so I will hand over to Simon. He will tell something about MPLS in general.
Okay, thanks. MPLS is a technology defined in RFC 3031 and is used to in provider backbones for labeling traffic to different sites, for example, and it's made for forwarding, and it's for performance reasons. You don't have a normal routing table like for IP. You don't have to route RTP packets. You can just route packets based on their MPLS label. which are 20-bit and so easily machine in hardware readable, and you don't need explicit software. And it's deployed in most carrier backbones. Also, it's used by many big enterprises to route in between their corporate networks, between their locations. You have different technologies. Some are called, the ones called layer 2 VPNs or layer 3 VPNs. In the layer 3 VPNs, you have IP routed infrastructure. So your core is IP based. In a layer 2 VPN, you can also have a core which is based on Ethernet. So you are forwarding directly Ethernet packets, or everything what's about Ethernet. And yeah, there are different terminologies for layer 2 and layer 3 VPNs. For this kind of talk, we will just call it layer 2 VPNs or layer 3 VPNs for the difference.
Okay, so an MPLS is used in almost every big provider backbone in the world. Okay, there are some kind of layer 3 VPNs where you're selling some kind of VPN service, and this is comparable to frame relay or ATM and stuff like that. It's highly virtualized, so you got a shared infrastructure, you got virtual separated routing processes on your PE routers, and additionally MPLS labels. So MPLS is used for forwarding on the one side, but it's used for client separation for the actually VPN service on the other side. So it's very flexible with the VPN topologies you want to build up. So you can do any-to-any topology, or you can set up some hub-spoke topologies, and nearly everything you can imagine in a VPN context. Okay, just to get you into the terminology. Okay. On this side, you got a provider backbone, which is just for forwarding purposes, and you got the VPN sides, which is the customer network. So you got a provider network. Inside the provider network, there are called P routers. P routers are just backbone routers in the ISP's backbone, which are strictly doing forwarding. They have nothing to do with the client side. They are only connected to the provider backbone, and they only know internal provider backbone routes. They don't know any shit about these client sides. So then there are the PE routers, the provider edges. These edges are actually doing the traffic separation. They do the initial traffic labeling, the traffic classification. So if the customer sends in some traffic, the PE router puts a sticker on it. Okay, this is red traffic. It has to go to the other side of the cloud. After that, MPLS is used for forwarding the traffic to the other PE router, which sees, okay, there is a red sticker on the traffic. This must be for customer side A. Okay, so you got the customer sides, and in the customer side, you got some CE routers, which are mainly for exchanging customer routes, because your